In episode 20 of Mobycast, Chris recaps another DockerCon 2018 session, How to Create Effective Container Images by Abby Fuller. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Here we go. Welcome, Chris and Rich, another Mobycast.
Hey, John. Hi, Rich.
How's it going, Rich?
Going good. How are you?
Good. What have you been up to this week?
I'm back home in New Jersey at a beach town called Long Beach Island. Currently in a closet trying to escape my cousin's children from being a little bit loud. But just got off the beach to do this podcast, so pretty stoked. I'm covered in sand and definitely relaxed. So I'm doing real well.
Keep that sand away from your Yeti microphone.
Yeah.
Is New Jersey one of those places where no matter whether you've lived more than half of your life away from it, you still say home when you go there? You still say, I'm back home?
I mean,
I think that Hawaii is kind of like that, and maybe California too.
You don't think that? Where did you grow up?
I grew up in Colorado.
No.
I haven't lived away from it long enough to know the answer to that question for myself, whether I would still call it home if I lived away from it for more than half my life. But I have noticed that people that move here often, after they live more than half their life here, they stop saying home about wherever place they came from.
If I'm in Colorado for half my life, I might do the same. It's weird for me though. My dad lives in LA, so home doesn't really exist anymore. But my extended family is here, and so I do say I'm headed home. Although I don't really, because I don't have a home to go home to. I sleep on couches.
Yeah, that's why it's sort of striking. Yeah, that's interesting.
And I certainly don't say LA is my home, because I have no ties to LA. It's just that's where my dad lives now.
Right. Well, cool. I hope you enjoy your time there. How about you, Chris? What have you been up to this week?
Let's see. This week I have been enjoying the arrival of summer here in Seattle. So now that we passed July 4th, July 5th usually marks the start of the summer season here in Seattle. So, and it's here. So it's really nice to see the sun. We get it for, I think, the next 3 months, and then it'll go away again. So we're soaking it up.
Is September like a super nice month in Seattle too? Is it sort of like the local summer, like all the kids are back in school, but it's really good temperatures and sunny?
Yes, September is usually gorgeous. It's very much kind of like an Indian summer type thing where just usually like very little rain, sunny, but the sun is starting to get lower in the sky. So it's a really nice time of year for sure.
Nice. Yeah, and as for me, I've been watching the World Cup, and I lived in England in 1998. I studied abroad, and so I have some ties to England, and I was just crushed when they lost to Croatia yesterday. And my sister lives there right now, and so that's yet another tie. And it just bothered me that they didn't win that game, like really deeply. So anyway, we have to try to pick myself up off the floor and do a Mobycast.
I should mention too, by the way, Tour de France is going full steam right now, and I'm a cycling nut, and so kind of the same deal. Like there's folks, World Cup's going on, people are really into that. Me personally, I'm in the Tour de France, and every day it's a 5-hour stage. So it kind of feels like doing a mini Tour de France myself, just trying to keep up and watch the coverage.
I expect that one of these days you're going to go to France and do, yourself. You'll pick one of your favorite tours and ride it.
Oh, absolutely. Definitely bucket list. So I will ride my bike up Mont Ventoux, and I will do Alpe d'Huez. Also, Paris-Roubaix is a race I want to go to someday, and to ride the Hell of the North and the cobbles, and to have beer and frites on the side of the road with all the mad Belgians as they go nuts. Bucket list.
Cool. So we're going to continue our series today from just kind of rehashing and talking through some of the talks some of the breakout sessions that you attended at DockerCon. Just, so many good things there, and we might as well kind of get those ideas out to a broader audience and put our spin on them. So you had said, which talk was it that you had said you wanted to do, Chris?
Yeah, so I went to a talk that was given by Abby Fuller, who's a senior technical evangelist at AWS, and she gave a talk on how do you go about creating effective container images? And this was a kind of a revamp, kind of like a remix of a talk that she gave at last year's DockerCon. So kind of continuing that theme. So all about just like, hey, you have this Docker file, you need to create a Docker image. Like, what are the best practices? Like, what are the things you should be thinking about from like a performance standpoint, from a cacheability standpoint, from a security standpoint? So pretty interesting talk with lots of practical information. This
is going to be really interesting for me too, because we did a Mobycast on this. I can't remember which one it was, maybe number 6 or so. Maybe Rich, I don't know if you have the ability to look that up, but maybe you can interject and let us know which one it was, on the same topic. So what I'm most curious to find out is what we left out, or what we thought of that she didn't. So here we go. Let's find out. Set the stage for us, Chris, please.
Sure. Yeah. So maybe to start with, it, kind of talking about just like, okay, what is a Docker file? How do Docker images like get composed? And so, one of the first things to talk about is just layers. Like, and so what are layers when it comes to Docker images? And so that's kind of an important concept when you go about, making your Docker file to create an image, is to understand that it's built up in these slices of code that are everything. And it's kind of like you can think of it as, a pyramid, or, just kind of like building up a building, each, floor at a time type thing. And it's building on top of the previous thing. And so you always start with some base layer, some base image, and then you're now making changes to that, deltas to that, with each new command in your Docker file to create a new layer that is just like I said, building on top of that until you kind of finish that all up. And when you're done making your modifications to whatever image it is that you're creating, that's your last layer. So it's a sequence of these layers. Each one of these layers corresponds to a command in your Docker file. And again, the important thing is you're starting with some base image, which has its own layer.
You said usually. I just out of curiosity, is it possible to not start with a base image?
I mean, you can start with a special one. It's called Scratch. And so Scratch basically says like, I'm starting with nothing, which is kind of interesting. Right? Cool. It's like, what does that even mean? Like, it's kind of hard to wrap your head around a little bit, because it's like, you need an operating system, right? So like,
right.
Like, how does that all work? And personally, I've never had a use case where it's like, I'm going to start from scratch, and do it. But, my understanding is like, if all you really wanted was a container that is just literally an executable, and it has like, there are languages and environments out there, runtime environments that kind of are dealing with this case, where I think basically you're kind of creating like the equivalent of like an ISO. And so Rust, I think, is one of those languages that you can say like, here's my program, go ahead. And when you compile this, I'm going to give you a flag that says basically turn this into like the self-running image type thing. And so for something like that, you would use like the Scratch as your base layer perhaps. And then that way you have a very minimal Docker image.
Hey, this is Rich. You might recognize me as the guy who introduces the show, but is pretty much silent during the meat of the podcast. The truth is, these topics are oftentimes incredibly complex, and I'm just too inexperienced to provide much value. What you might not know is that John and Chris created the training product to help developers of all skill sets get caught up to speed on AWS and Docker. If you're like me and feel underwater in these conversations, head on over to prodockertraining.com and get on the mailing list for the inaugural course. Okay, let's dive back in.
So then where do we go from here? We understand the concept of Docker file being layers.
Mm-hmm. Yeah. And so this is just, again, a very important concept, is to understand like it's built in these layers. Each one of these layers are individually addressed and cached. And this comes into play with a number of things. One is it's the number of layers that you have is going to determine, how big your Docker image is. And it's also going to determine how cacheable it is, and what happens to that cacheability when you make changes to your Docker file. And so, something to keep in mind, like Docker images can be very, very small if you've kind of built them in a very optimal way, or they can be like really large if you haven't really thought about it. So definitely have seen like Docker images that end up being over a gigabyte in size for literally just like a Python app, just because of the way that, it wasn't really optimization or kind of like thinking about how to lay this out wasn't really taken into consideration. Kind of just like the standard, like, oh, let me go figure out how to add this program and let me go add this dependency. And before you know it, it's over a gig in size. And when you have something like that and you're pushing and pulling to a remote repo, to store your Docker images, that size comes into play now quite heavily, right? Because now you have to download maybe one, like another person on the team that hasn't worked with an image yet. Now they have to go download a gig worth of data, right? Just to get going. And if they don't have a great internet connection, then they could be sitting there for a long time. So spending some time to understand how these layers work and how they correspond to the overall size to your images is pretty important. So size is a consideration. The other thing that's really important here is cacheability. So Docker, when you pull an image, when you have an image on your local machine running under Docker, Docker's going to save that away and store that, and so it's going to cache it based upon the tag and the layer, if you will. So it means that again, in that case where if we had like the 1 gigabyte Docker image, it may be composed of, I don't know, call it like 10 layers. And maybe the 9 of those layers end up being about like 900 megabytes worth of data. And it's only like the last layer that ends up being like call it 50 megabytes or something like that. If you kind of arrange it such that only the last layer is getting changed when your code changes, then now when you do subsequent pulls, Docker's going to say like, oh, I already have these 9 layers cached, and they match up with their tag. So I'm not going to go download them. I'm just going to load them from cache. I'm really going to go download this new layer that's 50 megabytes. So kind of basically you want to defer things that are changing to be like one of the last layers in your Docker image. And so that was kind of like one of the key concepts that was pointed out during this talk. And this is something, we definitely do all the time at Kelsus, and with something like Node, where you, as part of the build process of making your Docker image, you have to go out and fetch all your dependencies. Those dependencies are specified in a package JSON file. And if you, one of the tricks that kind of is related to this is what you want to do is you want to install your dependencies first, and then add your code in a separate layer. Because what that does, it means that it's only going to go do that expensive dependency install step if you actually change your dependency list, as opposed to if you do it after the code step, then it means whenever your code changes, it's going to break the cacheability. And so Docker's now always going to have to go do that dependency install, even though that stuff may not have changed. But because it comes later in the process, you broke the cacheability of it. So you now have to go redo that process.
I guess I'm a little confused. Is there some way that you're telling Docker this is a layer? Because I guess my confusion comes from, well, don't you always have to install your dependencies before you install your code? Isn't there no way to mess this up?
Yeah, so you do tell Docker what's a layer, and by virtue of the fact that every command in your Docker file generates a layer. So that's kind of an important thing to do.
I guess that's what I was getting at, right? So if you have code dependencies, I mean, the very definition, the word itself, dependency, sort of means do these first, and then you can then your code can do what it needs to do. So isn't it just sort of, something you don't even need to consider? Like, of course your dependencies are going to go in first.
It's a little bit more subtle, but like once you kind of think about it from a layer standpoint. So every add or copy command that you do in your Docker, so you use add and copy in your Docker file to say like, I'm going to like when I build this Docker image, these are the files I want to copy over into the actual image itself to be part of it. And that creates a layer. And so
I see. So you could potentially put some copy command that did some, or add command that put some files on your Docker image that represent dependencies before you put your, or, after you put your files on that represent your code. And that would be backwards.
Right. Yeah. So the idea here is that your dependencies is changing much less frequently than your actual source code. So what you would do is you build up your Docker file is you would first do something like, hey, add my dependency spec file. So like I'm going to add package.json. And then after that, then I'm going to say npm install. So go install all my dependencies. So now I've created 2 layers, right? I have a layer for the package.json file that I added to the file system. Then I did another layer with running the npm build, npm install. And now for my third layer, I can say, now do another add command. And now I can go add all of the rest of the source code. And that may have been in the same place as package.json. And I could have done like add basically the equivalent of star, right? Star.star. But instead I said, no, I'm going to just do add package.json. And that's in that layer. And now I'll come back and now add the rest of it. So now I can do the add star.star.
Now I get it. Thank you. That's what I needed.
Right. So that, and almost every application language out there has this kind of concept. Python has the same thing with it, with pip install, and having your dependencies. So a very common technique that really pays off, and it really increases the build time to build your images, by having this good cacheability and basically only rebuilding the things that need to be rebuilt that have actually changed, type thing. So definitely something, a good technique to use.
Cool.
Maybe, yeah.
So we're at the risk of running over a little bit, but I think we should keep going, because I think this could be helpful for people that are working through, getting their head around how to do best practices with building Docker images. But maybe we can kind of take a quick pause to say what are the pieces we have left to talk about.
Yeah, so I think definitely one of the next kind of big topics would be like, okay, base image, like what base image should I choose, right? To start off to build my Docker, because this is actually one of the first choices you have to make when you want to Dockerize something, when you want to create a Docker file, is saying, what is my base image? So there's considerations there, and that's something to kind of talk through. There's also, we can talk about multistage builds, is a kind of an interesting, important topic as well. And there are some other issues like security considerations and kind of cleaning up and making sure that things aren't just garbage collection. How do you do garbage collection from all the artifacts that are created as part of this? So I think maybe in this session, definitely talking about like base image, like what are the considerations there, and how do you go about doing that? And then we can see about maybe doing a next time talking about multi-stage builds, and some of the other things around it, because those are pretty interesting topics as well.
That sounds good. And then I remember that we talked quite a bit about base images in that previous conversation that we had that had essentially the same topic. Rich, you didn't happen to get a chance to figure out which number that was, did you?
I think it's episode 6 and 7. We have how to create Docker containers part 1 and 2.
Okay, cool. And we talked a lot about base images and those, and we talked about, the different, how to choose between a base image that hardly has anything on it versus one that has a ton of dependencies already on it for, maybe you're using Django or maybe you're using Rails and maybe there's, a bunch of stuff you already know that you need in there. And then we also talked about building your own custom base images that have pre-built some of the libraries that you might want. Is that some of the same stuff that Abby discussed in her talk?
Yeah, absolutely. So I think what we talked about then is definitely matches up with the advice that Abby had as well. So understanding so your base image is going to determine a couple things. One is going to determine the overall size of your Docker image. It's also going to determine the kind of the security footprint that you need to manage and kind of be concerned with, right? So the bigger image, again, the bigger your footprint, the more you have to like worry about like holes and security issues and whatnot, because you just have more software running. So there is the trade-off, right? This is one of the things that she kind of went into as well, is just like, look, we could all say just go use Alpine as your base image, and it ends up being, you know, like 4 megabytes is the base image size for Alpine, versus something like Ubuntu might be like 80 megs, so 20 times the size of it. And given that smaller size, you have just, there's less code in there, so it's much more secure because there's just less code to be exploited. But it comes at a cost, which is that it's much more difficult to work with, right? Like you now have to you may have install a new package manager, or you may need to you may need compile tool support. You may need other libraries that need to be installed and whatnot. So it becomes much less developer friendly. And you also may have to think about like, well, security footprint is better because it's smaller, but maybe there's actually software I have to add to increase the security, right? That's in that space. So just lots of trade-offs to consider. And it's just important to know that like these are the issues and the considerations, given that but in general, the recommendation is like the smaller your base image, probably the better off you are, unless you have good reasons for not doing that.
Right. I guess one of the things that occurs to me is that you might, especially in terms of the security piece, that you might go get a small base image, but then if you have to add a bunch of libraries and other packages to it, then all of a sudden you're responsible for the overall security of all of the software that you put on your base image. Whereas if you get a really popular base image that has more of what you need on it, if there turns out to be a security problem with that base image, you might find out about it from the, World Wide Web, as opposed to finding out about it from, oh gosh, I shouldn't have put that, package or library on my container, on my image after getting this more secure base image. You know what I mean? Like there's sort of safety in numbers in a way.
Yeah, for sure. Especially like if it's, like you said, if it's something that there's lots of eyeballs on it, there's lots of folks using it, it's a very popular distribution, then there is definitely some safety in numbers there, right? Because it just means that it's much more likely that something is going to be caught and then definitely be fixed, as opposed to if that burden is moved to yourself. You can mitigate this quite a bit with having a scanning surface,
sure.
Running on this. So like you can absolutely, like all the, packages running against a CVE database, whether you use Docker Trusted Registry or, something like one of the tools like from Aqua Security or whatnot, there's plenty of ways to go scan your images, and that should just be part of your build process. And so you would be alerted to those kinds of things. But it's just, again, trade-offs, and just understand like what responsibility you're assuming versus someone else. For me, it's also kind of dangerous too and scary to say like, I'm going to put a lot of faith in someone else. Maybe not so much in like these. That's why if it's a package or distribution that has lots of eyeballs on it, and it's basically coming from a source that I really trust, then I have to worry less about it. But when you get down into like the dependency level, in the ecosystems that exist for things like Node and Python, just understanding what it means when you're just like installing some package, something to be aware of. Right.
So I think that we've sort of often taken the route of, let's get something that has quite a few of our dependencies on it, and then essentially fork it, build our own base image from there with the additional things that we always use, and then maintain our own base image after that. Right.
Yeah. And I think that's what I think we talked about this in that previous episode, but absolutely, if you kind of are building more than one application, so you have more than one Docker file, and you kind of have a common way of building out your applications, like you have kind of your own standard microservices framework with all the various standard pieces of infrastructure that goes along with that, like things like logging and instrumentation, and just setting up like routes and endpoints and listeners and port configuration or whatever, then absolutely like go and do those best practices to build your own base, that will serve as your own base image, and then just inherit off of that, as opposed to kind of like making each team go and figure that out on them, for themselves. So definitely a very good technique to do is like do it once, and then, in the spirit of reusability, now have projects use that as their base image, not go reinvent the wheel each time.
But then at that point, you've given yourself a bit of a technical loan. You've got some technical debt going, because if you don't remember at least once a quarter, maybe twice a year, to go peer at the base image that you initially inherited from to see, has this thing changed? Do I need to rebuild this with a new version of the base image? Then you could be in bad shape.
Yeah, absolutely. So software's hard work, isn't it? It's like there's definitely no silver bullet here that makes things super easy to do. It's it's always kind of like trade-offs and finding that right mix of what it is. But absolutely, like you can't let your base image now go rot in technical debt. You need to keep it up to date. So you need someone that's responsible for doing that, for making sure that it has all the latest patches, that it's being kept up to date, that the dependencies are being refreshed accordingly. You now have issues with like backwards compatibility perhaps, and some of those things may be breaking to some of your applications, especially if they haven't been changed in a while. So lots of things to consider.
Right on. So one last nod to Abby. Is there anything else that she brought up on base images that we didn't talk about that's particularly important, or did we cover it? No, I think for as far as like base images go, I think we're good there. Cool. And then of course we have those other topics that we can hit next time, but we've run close to half an hour, and by now, our poor listeners are sitting in a garage somewhere and trying to get into work. So let's let them get to their job.
All right. Sounds good.
Thank you very much, Chris. That was really informative. And thanks for joining us, Rich.
All right. Thanks, guys. All right. See you next week.
See you. Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/20. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.